Hey guys, today we're going to talk about inequalities within triangles, but before we do that, I want to go through some of this vocab again. This is all stuff that we've done throughout the unit. There's another copy of this on the back page of your notes that I want you to follow along with and fill out. I know you've already filled it out once, but I want you to do it again just to get really familiar with it. So a midsegment connects midpoints. So that right there is a midsegment. It connects midpoints of two sides of a triangle. There is no point of concurrency, and that's because if we draw in all three of the midsegments, they're going to look like that, and they don't actually all intersect in one point, so there is no point of concurrency. Next is angle bisectors. So an angle bisector cuts an angle in half. If we draw in all three, they will all meet at one point, so they are concurrent. Okay, so an angle bisector cuts an angle in half. The point of concurrency is called the incenter. And that point is equidistant from the sides of the triangle. Angle bisectors are always inside of a triangle. So whether you're looking at a right triangle obtuse or acute, it will always be inside of the triangle. Okay, and that point is equidistant from the three sides. So this perpendicular length, and this perpendicular length, and this perpendicular length are all the same. Perpendicular bisectors. So that's a perpendicular bisector. It cuts a side in half, and it's perpendicular to that side. So it's perpendicular to a side at its midpoint. If I draw in all three perpendicular bisectors, they will all meet at one point. And that point is called the centroid. And it is equidistant from the vertices. So the distance from this centroid to here, here, and here are all the same. That is not always inside of a triangle. If it's right, it is on the hypotenuse. If the triangle is obtuse, that is outside, and acute, it will be inside. A median connects a vertex to the midpoint of the opposite side. If I draw in all three of them, they will all meet at one point. That point of concurrency is called the centroid. In every kind of triangle that is inside. and then the altitude. Altitude always extends from a vertex, and it has to be perpendicular to the opposite side. If I draw in all three altitudes, they will be concurrent. That point of concurrency is called the orthocenter. In a right triangle, that orthocenter is on the right angle. In an obtuse triangle, it will be outside the triangle, and in an acute triangle, it will be inside the triangle. Point of concurrency is where three or more lines intersect. Inscribed is something that is drawn inside of something. In the case of this unit, it's talking about a circle drawn inside of a triangle, specifically in the angle bisectors. This point, this incenter, is equidistant from the sides, which means it is the center of the inscribed circle. Circumscribed means drawn around. And in the case of perpendicular bisectors, they're equidistant from the vertices. Or that point there, the centroid, is equidistant from the vertices, which means it is the center of the circumscribed circle. Now we'll get to inequalities in a triangle. Mark the largest angle and the smallest angle, as well as the shortest side and the longest side. So here's the largest angle, and here is the smallest angle. This is the longest side, and this is the shortest side. And what we should notice is that the longest and largest are across from each other, as well as the smallest and the shortest being across from each other. The longest side and the largest angle are opposite each other. The shortest side and the smallest angle are opposite each other. So if one side of a triangle is longer than another, then the angle opposite the longer side is larger than the angle opposite the shorter side. So in this case, AB is longer than BC. AB is 8, BC is 5, so AB is longer. That means the angle across from AB, which would be angle C, has a greater measure than the one across from the shorter side, angle A. And conversely, if one angle is larger than another, then the side opposite the larger angle is longer than the side opposite the smaller angle. So here, angle A is bigger than angle C, so across from angle A, the length of BC is greater than across from C, the length of AB. A long-tailed boat leaves a dock and travels to a cave. In case you're wondering what that even means, a long-tail boat, it looks like that. So one of those kind of boats leaves a dock and travels to a cave 2,500 feet away. So the boat leaves the dock, goes to the cave 2,500 feet away. Then it travels 5,000 feet to a beach, and then 6,000 feet back to the dock. One of the angles is about 55. One is about 24. What is the angle measure of the path made at the cave? So I want to know that angle measure right there. Okay, so the cave is opposite the longest side. So by Theorem 510, that cave angle is the largest angle. Okay, opposite each other, longest side and largest angle. The angle measures are always going to add up to 180 inside of a triangle. So the third angle measure can be found by doing 180 minus the two that we know. We know two angles are 55 degrees and 24 degrees. 180 minus 55 minus 24, that's taking away 79, so it's 101 degrees. So our three angles are 55, 24, and 101. The cave is across from the longest spot, so it has to be the largest angle, which is 101. Okay, so this one right here is 101 degrees. Now let's just go ahead and place the other two. 55 and the 24. 24 is the smallest. It's going to be across from the shortest side. So this is my 24 degree angle here, which means this right here is my 55 degree angle. List the sides of triangle PQR in order from shortest to longest. So we'll go short, medium, long. The smallest angle is right here, 45 degrees. Across from that is the shortest side, and that's QR. The largest angle is 80. Across from that is the longest side, PR. And the remaining side, that's our middle, that is PQ. Another boat makes a trip, and the paths of that trip are 1.5 miles, 2 miles, and 2.5 miles long. Angles are 90, about 53, and about 37. Sketch and label a diagram with the shortest side on the bottom, the right angle at the right. The shortest side has to be on the bottom, and that would be 1.5 miles. Okay, so then the right angle is at the right. So it's either here or it's going to be up here. We're going to need to put it down here. We'll make that a right angle. Now that 90 is going to be the biggest angle, which means across from it is the biggest side. So that's 2.5 miles. Which means this one is 2 miles. Across from the smallest side is the smallest angle, so 37 degrees right here. And 2 is our medium side. Across from that is the medium angle, 53 degrees. Another theorem, the triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third. So that means that if I add up sides AB and BC, what I get from that would have to be bigger than AC. If I add up AC and AB, that has to be bigger than BC. If I add AC and BC, that has to be bigger than AB. So no matter what two sides I add, they have to be bigger than the remaining side. So if I said that three sides of a triangle are 10, 12, and 14, no matter what two sides I add up, they have to be bigger than the remaining side. The only side that we actually have to check is the two shorter sides and make sure they add up to something longer than the longest side. If I add the longest side with anything else, the longest side by itself is longer than anything else. So I really just need to check, is 10 plus 12 greater than 14? And it is, that's 22. So this can make a triangle. So if the question is, can these be the sides of a triangle? Yes, they can. If the sides are, say, 5, 9, and 16. The two shorter sides, 5 plus 9, is greater than 16. 5 plus 9 is 14. That is not greater than 16. So no, these three sides cannot make a triangle. What if the sides are 5, 5, and 10? The two shorter sides, 5 plus 5, are greater than 10? Nope, that's not true. They equal 10. They can't be equal. So the answer is no. They cannot make a triangle. Now a triangle has one side of 14 and another that's 10. Describe the possible lengths for the third side. That third side can't be just anything. That third side has to fit within this idea that the two shortest have to add up to something longer than the third side. So here's how I can find possible values for that third side. 14 minus 10 is 4. So if I said my last side was 4, 4 plus 10 is not greater than 14. It can't be 4. But if I had like a 4.1 or even a 4.0001 plus 10, that would be greater than 14. So anything that is greater than 4 will work. Up to a certain point, because then it could get to where my third side is the longest. And the 14 and 10 might not add up to be enough. So 14 plus 10 is 24. Now I can't have 24 because 14 plus 10 is not greater than 24, but 23.9 would work. 14 plus 10 is greater than 23.9. So I can't use 24, but what I can do is use anything bigger than 4, but also smaller than 24. So we're going to go right down to this last line here. The length of the third side must be bigger than 4, and smaller than 24. Okay? Another way to write that, we'll call the third side x. X has to be greater than 4 and less than 24. Notice it's not or equal to, it's just greater than 4, less than 24. So a triangle has sides of 23 meters and 17 meters. Describe the possible lengths of the third side. 23 minus 17 is 6, and 23 plus 17 is 40. That means the third side has to be bigger than 6, but smaller than 40. So x is greater than 6, but less than 40. And that is measured in meters.